Introduction, Materials, and Procedure. Students will be asked to determine the effect on the period of a pendulum's oscillations by separately varying the mass and the displacement of the pendulum bob. So that's the first thing we'll be doing. Then secondly and independently, we will change the length of the string. Our list of materials, right over here. Small pendulum bobs, steel, wooden, and aluminum, and various other pieces of equipment. A simple pendulum consists of a pendulum bob, that's this little weight at the end of the string, and it's suspended from a support, here's our support and our stand, by a thread or string. A complete swing of the pendulum is over and back. So if we start the pendulum at this point, it swings over here, comes on back, that time there is 1 period, and we want to measure that in seconds. Before the students arrive, you should have, for every group of 4 students, the pendulum support and stand, the nylon thread, meter stick, 3 different pendulum bobs, and balances. Make sure that the balances and stopwatches are functioning. There are 2 parts to the lab. In the first part, we'll vary the masses and displacement. The displacement is the angle theta, and we'll calculate the period. In the second part, we'll keep the mass and displacement constant, and we will change the length of the pendulum. So first, measure the mass of the bobs and length of the pendulum and record these in data table 1. So the length is the length of the string plus the distance to the center of the mass of the pendulum. So just go ahead and approximate that. It's probably in the middle somewhere. Displace the bob from the equilibrium position at an angle of 5 degrees as measured by the protractor. That is less than 15, so we use the small angle approximation, so our equations all work. Release it, recording the time for 10 full back and forth oscillations. We will divide that time by 10 to get the period. Repeat the time measurement for all of the mass displacement combinations in data table 1, where the displacement is the angle theta, and we'll have 3 different angles that we'll be using. They're labeled small, medium, and large. And be sure to keep the pendulum length constant when the mass is changed. Record all data in data table 1. Once the first set of data has been collected, select one mass, one of the pendulum bobs, for the pendulum. Keep this mass for the remainder of the lab. Set the pendulum string length to 20 centimeters. Displace the bob from the equilibrium position at angles between 5 and 15 degrees and release it, recording the time for 10 full back and forth oscillations. Then we will continually change the pendulum string length for the remaining 20 centimeter increments in data table 2. Repeat step 6. Be sure to measure the length of the pendulum carefully and release it from the same angle set in step 6. So whichever one you pick here, keep that same angle. Record all data in data table 2. Warnings. Be sure that the stand and the support for the pendulum remain secure and stable. Emphasize that students should be careful when handling the pendulum bobs. It's potentially dangerous if the bobs are thrown, swung forcefully on the string, or handled in any other way than what is given in the instructions in the lab. Wear safety goggles, especially since students may sit close to where the pendulum swings. Please use this for data table 1. The periods for each type of pendulum will be calculated and compared. So let's see, the mass of the bob, the length of the pendulum, number of vibrations, elapsed time, and then period. And here's what you use for the second part of the lab. You can see how we're changing the length of the pendulum. We still do the same amount of oscillations or vibrations, 10, and then we can calculate the period. Please click over here to see a video demonstration of the lab procedure. Tips for performing the experiment. Be sure to release the pendulum bob from its initial position without pushing it forward. You just want gravity to be the only force acting on the bob. Start the timer immediately upon releasing the bob After a few swings, the pendulum will have decreased periods due to the friction between the spring and the support. If you notice the pendulum support swaying or the string moving at the fulcrum, stabilize it with your hand. And remember, use small angles between 0 and 15 degrees when displacing the pendulum bob.